Okay, welcome back. This is my part 3 videos of exponential logarithms. So now I want to talk about some properties of the natural log, the log, and I'm going to give us some examples of exponential problems solving for the exponent. So first I'm going to look at some properties. First two go together. These are the really two important properties that we need to understand. In our previous lessons, I've talked about log and 10 being paired up. So this property demonstrates that log of 10, they cancel each other out. So when you think of log, I want you to automatically think of 10. Now, I want to explain why it's 1. Technically, it's log 10. That's the base. So the base is 10, my exponent is the 1, and we set it equal to this 10. Is that a true statement? Absolutely it is. Now, anytime we have 10 or log, think about you paired up with the other. Same thing with the ln and e. The e is a base, and it's got a value similar to pi. The e's value is 2.72. Now, ln and e cancel each other out, so I want you to remember to pair them up, and it forms a 1. Now, my next two, I've got log of 1 and ln of 1. So if you all want to punch this in your calculator to make sure that this is correctly, your log is on the left-hand side of your calculator, and so is your ln. And your e, there's two ways to find e. One is if you hit on your graphing calculator, your TI-83 or 84, hit second in the ln button, it gives you e, and it raises to an exponent. Or if you hit second and go to your division symbol on the right, there's the little e there, and if you hit that and hit enter, that gives you that value 2.72 rounded. Now let's look at log 1 equals 0. Now remember, it's an understood base 10. So what I'm going to say is I'm going to say my base is 10 raised to the 0 equals 1. If you punch that in your calculator, that is a true statement. ln of 1, punch that in your calculator and you get 0. Now, here's what I mean by canceling each other out. You see your ln and e? Your 7 will drop down, and ln of e is 1, so 7 times 1 is 7. Same thing with your log of 10. Log of 10 is 1, so 5 times 1 is 5. And we're going to demonstrate this here later on in my examples. On my fourth part of my video series, which will be next. So let's take a look at this. Example number 1. 3 to the x equals 9. Well, most of us in here will say, or our brain will say, x has to be 2. Because 3 squared is 9. And that is correct. However, I'm going to show you something. Let's use our power rule right here. If I bring my x down, log is always involved. If you do to one side, you also have to put log of, in this case, 9. Now what we want to do is we want to solve for x by divided by log of 3. Now, we're not going to say logs cancel each other out. 3 goes into 9 3 times. That's your answer. This right here is not how you do it. But what you do is you'd say x equals log 9 divided by log 3. Now, depending on with your calculators, what I always like to do is put everything in parentheses. So when you put in log 9, you can hit enter and then hit divided by log 3. That's another way to do this. You come up with 2. So now the great question that I hear is why in the world, if our brain tells us it's 2, that we go with this complex method of using logarithms to solve this exponential problem. So let me scroll down to my example number 2. And here's the reason why. Think about this, okay? What is x? What can x be? Well, what I like to do is, okay, 3, if I use squared, 3 squared is 9. But if I say 3 to the third power, that is 27. So I know that it has to, 15 is between 9 and 27, so that means the exponent has to be between 2 and 3. So let's use what we've learned. Let's bring the exponent down by saying x log 3 equals log 15. Divide by log 3, divide by log 3. From in parentheses. So x in this case is going to be 2.4650. Now notice I want to use 4 decimals because the more decimals you use, the more accurate your answer is going to be when you check it. So what I'm going to do is I'm going to check my answer. I want to say 3 to what I found x to be, 2.4650. And if I do this, I get 15.000 and so forth. So that is what your answer is fairly a really good estimate, really good answer. Number 3. Now, going back to our first video, I left you when I was doing going from exponential to logarithm and logarithm to exponential. I left this saying we would come back to it. Now this is the point. So now what we can do is we can bring the x down and say x log 6 equals log 35. Then what I want to do is divide by log 6. Have everything in parentheses, or just say log 35, hit enter, divided by log 6, enter. And look what x is, 1.9842. So from that first video, I compared this 6x equals 35 to the same thing as 6x to the 36. And I knew 6 squared is 36. So I knew x is going to be a little bit less than 2. And finally, my last example of this, or my last 2 examples of this video. 7x equals 84. The same process. Now also, if you want to say 7 squared is 49, 7 to the third. So if I do 7 to the third, you should get 343. So I know the x is going to be between 2 and 3. So that's going to be x log 7 equals log 84. I'm going to divide by log 7. Divide by log 7. X equals, so in my case, it's going to be 2.2770. So if I want to check my work, I could say 7 raised to the 2.2770, and this comes out to be 84.0017. That's pretty close to 84. So remember, the more decimals you use, the more accurate your answer is when you check it off. Finally, I'm giving us now one that's a little bit more complicated because I'm throwing in 18x plus 6. I'm just not throwing us in just an x. I'm going to add some things to this. But what I want you to do is put parentheses around the exponent, and I'm going to bring it down, just like I have been before. And then that makes that log 4 equals log 7650. Next step, divide by log 4, divide by log 4. So I've got 18x plus 6 equals, so when I take log 7650 divided by log of 4, I get 6.4506. Now this is going to be a two-step equation. I'm going to subtract 6 on both sides. We'll have 18x equals 0.4506. Divide by 18, divide by 18. In this case, x equals 0.0250. So this concludes my third video of the installments of exponential logarithms. I hope to hear from you in video number 4. Thank you very much.